Welcome to this web lecture on user interface design principles. We are going to learn how to design interfaces so that likely they will result in a good user experience. A lot of this advice will be in the form of do's and don'ts of interface design. This advice actually comes from studying many examples and generalizing what we see in these examples. That is the experience-based or empirical research that results in us knowing what to do. But some of the advice also comes from psychology, where theory-based knowledge is used to give you the advice, and some of it is just common sense. But we already know that common sense is something that, even though we all have it, we don't often use it. The principles, of which we use 7, and will be dealt with separately in detail in different web lectures. The first principle is that of visibility, which just means that we have to place the controls like buttons, switches, sliders, where the users are going to see them, and the effect of pressing a control button or turning a knob or using a slider must be immediately visible, so the feedback needs to also be visible with the control. Controls need to be where users can see them, obviously. Right? That's visibility, but it's more than that. They also need to be where users expect them, because there is a big difference between seeing and looking. Now, when we group input and output, we can already assure that when the input is found, you press the button, that the effect of the action can also be seen. And to help us with the expectation, we can follow standards. Right? Even when a user sees a new interface, if it's similar to an existing interface that is standardized, right, the user will automatically be able to use the new interface. A quick look at an example. In a friend's house, people have trouble figuring out how to flush the toilet. What is the problem here? The button is on the floor, where users can see them. But the button cannot really be seen when users are looking where they expect to find the button to flush the toilet. And that's why all of these 4 principles have to be followed in order to have an interface that users can use. The feedback is not only a matter of location, but also of being immediate. In this overly complex interface to turn on and off the lights, you press the up arrow, the display immediately says on, and you press the down arrow, it's off. It's immediately clear that you press the button, the system has understood this. I've often seen people enter an elevator and they press button for 5 and the light doesn't come on. People do not think, oh, the light doesn't come on, it must be broken. No, they think the light doesn't come on, I didn't press well enough, and they will inevitably all press again. Then there are constraints that prevent us from doing the wrong action. Right? And if we can't do the wrong action, we are more likely to actually perform the right action. Simple, but in practice, not so easy to implement. There are 3 main types. There are the physical constraints. Obviously, when you look at this key and you see the lock, the key will fit only one way into the lock. The physical constraint of the lock and key help us in using the key in the proper way. Then there are logical constraints that actually have a similar function. If we look at this menu, some items are grayed out. And with common sense and perhaps a little bit of trial and error, you immediately find out that the grayed out menu items don't work. But then there are also cultural constraints. if you haven't been told or you haven't read what the signals mean, you wouldn't know. Common sense isn't going to help you to figure out, for instance, that a red triangle means danger. There's nothing in nature that tells us that. So traffic signs are a good example of cultural constraints. Then we can also make use of mapping from interface to real world. The layout and the actions used in the interface can be made to resemble their equivalent in the real world. Take, for instance, the buttons used to open and close the windows in a car. The image here shows the buttons from the Toyota Prius, happens to be the car that I drive. And we see the 4 buttons laid out in the same way as where the 4 windows are in the car. So if you want to open the right rear window, the interface immediately makes it obvious you have to use the button at the back right. But it's not only the layout that works here, it's also the actions. If you pull up the button, then the window rolls up, and if you push down on the button, the window rolls down. Clear mapping from interface to real world. Then there is the issue of consistency. Again, a very simple principle. Make the interface for a new task similar to the interfaces that already exist for similar tasks. So when you present your new interface for the first time to a user, they will know how to use it. Right? They say, oh, yeah, it's just like this other thing and no manual needed. Interfaces that are consistent within the interface and with other interfaces are easier to learn. They're easier to use and to remember. Right? Even if you don't use a program very often, right? If it's similar to other programs you do use, right? Then you will remember how to use it. Here is a simple exercise for you. Well, look at these 2 keyboards. They are different. The one on the left is a phone keyboard, and the one on the right is a calculator. We are used to this inconsistency between these very different layouts. Now try to type a phone number on a calculator keyboard. You will have a very strange experience because it's hard to do that. When you know the phone number to type, your memory actually knows which movements to make on a phone keyboard. And you will have difficulty on the calculator keyboard. This inconsistency between these 2 types of keyboards we can no longer solve. This has been created historically, and we have to live with it. But when you create new interfaces, look for similar interfaces that already exist, and do not change the way the interface works. Then there are the affordances. And affordances, right, it includes the word afford. Right? It's an interface that invites you, right, that is suitable to perform a certain action. The interface itself already gives you a clue as to what to do. For instance, a doorknob. Right? The door handle is obvious because everyone with common sense sees that, oh, this handle can only turn along its axle, and the way our wrist and arm and hand actually works, we can only turn this way. It would be hard for us to turn to upwards. Right? So everyone can use this interface. You don't have to learn it. You very quickly, with common sense, find out how that is done. The same we can do in computer interfaces. Buttons are easy to understand, especially because we give them a 3D effect. You press on a button, it looks like the button is pressed into the screen. Now, we we know that really the screen is flat, right? But a pseudo 3D effect is used that gives you the feeling you are pressing on a button and you immediately know how that works. Then there is a final and difficult topic, which is quality of service. It is not really something you design, but it must be a property of the system as a whole that you create to avoid users from being frustrated because the system just doesn't feel right. It refers to two main constraints, the first of which is robustness. The system must seem to be reliable. It must appear to be reliable. The best way to do this is to make sure that your system is reliable. It is nowadays not acceptable that something that uses computer software crashes. We are so used to things crashing that we think this is normal. No, we should never accept crashes to be normal. But if we look, for instance, at the Windows interface or the Macintosh Finder, these programs do sometimes crash. But they restart so quickly that many users do not notice the crash. Well, for the quality of service design principle, this is already enough. A system is robust if the user doesn't notice that it isn't robust. The second principle is response time. If we have even just 1/4 second of delay between pressing a button and the interface reacting, the first reaction of the interface, we feel that the system is sluggish. This happens many times. For instance, on a phone, you press on the icon for an application and only 1/4 second later you hear the phone click sound. This is a bad phone, sluggish. With websites, we give them a little bit more time. We already notice that a website is sluggish when it has a 1/4 second delay. But if you want something more complex from a website, like you search for information, if you don't get an answer within 8 seconds, you will simply give up and go to a different website. So we have become impatient. And we need to design our interfaces so that they always have a good response time, which doesn't mean that they have completed the task within less than 1/10 of a second, but they need to show a reaction immediately. Now that we've studied these principles, we can update our individual assignment that we made in the introductory lectures. So we found an example in our environment where some design principle was violated. But until this lecture, we couldn't name the problem. You found a problem maybe because of visibility. Maybe it was an inconsistency. Maybe something wasn't really reliable. Doesn't matter, right? But now you can actually update your assignment, right, and add the explanation. Right? Which of these design principles was actually violated, right, in the example that you found. You have to submit this explanation to our Sakai site before the end of week 1. We will study the design principles more in detail in the separate web lectures, right, which will help you in performing this assignment. Thank you for participating.